Gonna go ahead and get started. So this talk is titled High Fidelity AR using the lightweight render pipeline. My name is Dan Miller. I work for Unity Technologies as an AR VR evangelist. And if you guys like what you see here or are interested in more AR Unity related content, feel free to follow me on Twitter at DanMillerDev. And what I want to do is I want to hop in and first just kind of tell you a little bit about what AR Foundation is, where it's at today, some of the future roadmap, where it's going. I'm going to show a demo that I made using AR Foundation as well as the lightweight render pipeline and some of these new features in Unity. We'll kind of go over how the lightweight render pipeline works with AR Foundation, what are the supported versions, and what are the plans moving forward. And then I'm going to break down just some of the visual effects that you're actually seeing in the demo, how we're able to do them, what we're able to do, so that you can start to understand and adapt these and bring them into your own projects. So what is AR Foundation? AR Foundation is a cross-platform API that takes the fundamental technology of ARKit and AR Core and sits on top of that, kind of abstracting them into just AR components. So you're not looking for platform-specific features. You're just looking for things like AR planes rather than specifically ARKit or AR Core planes. And what it allows you to really do is, as a Unity developer, you can have a single project, build it on top of AR technology, and if you build it out to iOS, it'll plug in ARKit. If you build it out to Android, it'll plug in AR Core. So it's really that kind of Unity idea of building once and deploying to different platforms. And we've rolled that into what we call handheld or mobile AR. So currently, what you might do if you're building an ARKit or an AR Core app is you take this kind of linear path. So you have your Android or iOS device, you're using the fundamental SDK that's built by the platform providers. So ARKit is Apple's AR SDK, AR Core is Google's AR SDK. There is respective Unity plugins that cover the full feature set for those. And then you'll kind of build your ARKit or AR Core app. What we're doing with AR Foundation is we're basically taking that same initial path, but instead of bringing it into the standalone plugin, we're using the AR Core and the ARKit XR packages. So AR Foundation is enabled through the package manager. And what we're able to do with the package implementation of ARKit and AR Core is really kind of update those and streamline them into the editor without having to wait for full editor releases. Because they're in a package, we can start adding that new functionality, updating it as they get released. And then AR Foundation is an additional package that sits on top of that and really kind of glues these functionalities together, gives you these AR-specific features that you want, and then you're able to build your multi-platform AR application there. So one of the things to keep in mind about AR Foundation in its current state is it does kind of only cover some of the fundamental technologies that are shared between ARKit and AR Core, and that's how it really started out. But now we're evolving it into more of those unique functionalities. So really today it's available as a preview package. As I mentioned, it covers those core functionalities, which you can consider things like horizontal and vertical plane finding, hit testing, light estimation. It does have some unique camera image APIs. If you're looking to do something like computer vision against the camera image, you can kind of return that in a very easily understandable way that you can start to feed into different algorithms. And we do have lightweight render pipeline support. And last but not least, we kind of have this sample project called the AR Foundation Samples, which is a nice asset of a project already configured using AR Foundation. There's things like the lightweight render pipeline branch is supported on there. And there's even some nice kind of UI and UX. So if you want to start placing content, have this kind of clean implementation, rendering planes, having them kind of fade off, that's all included in the sample project here. And I've actually helped out a bit kind of contributing to that. So as mentioned earlier, the kind of supported features right now are in this more core functionality. So you see all the green checkboxes in the AR Foundation column there at the top, which obviously plane detection, feature point, light estimation. We've added some of the unique features that are only available on certain platforms. So you're looking at things like world maps, which is an AR Kit specific feature that has been enabled in AR Foundation. We also have face tracking, which is an AR Kit supported feature. AR Core very recently added face tracking. And the idea there is that if you're building with AR Foundation, once the kind of feature is supported in both SDKs, we'll be able to kind of plug it in there behind the scenes so that you can just recompile your application, start building for the other platform. You can see we also have some unique features like remoting, simulation. The lightweight render pipeline support is only available via AR Foundation, and I'll be touching on kind of how you can utilize that and things like that. And lastly, that camera image API, which I mentioned earlier. And obviously the real goal here of AR Foundation is to completely fill up the AR Foundation column with all of the unique and shared features. And as the different platforms kind of catch up, add more functionality, we can utilize those hooks that we've already put in place. So where is AR Foundation going? Well, as mentioned, we really want to get up to feature parity with all of those unique and shared features for both AR Kit 2.0 and AR Core 1.7. Those are the latest iterations of the respective SDKs. And we've also announced that we're going to support wearable devices. So if you think about kind of the bread and butter functionality of what the mobile SDKs can do, both plane finding and placing content on it, and you look at what the wearable technology can do today, we see a lot of kind of overlaps where we can still abstract that AR functionality and bring those to different platforms. We also have things like the AR remote. So this is a little screenshot of the editor here where we're able to connect an AR-enabled device to the Unity editor and then start building on top of it. You don't have to compile out to the device. It kind of remotely connects. You can see I'm kind of placing content in both the scene and the camera feed into the world. And you can also kind of place more complex content and really just start to build and iterate without having to fully compile out. And lastly, we're building some simulations so that we can kind of simulate these experiences without having to remote, which really just keeps the workflow in the editor as you start to develop. All right, now the fun part. So I'm going to throw this down so that it tracks a little bit better since the carpet is kind of all one color. Please don't step on it or steal it. And what I'm going to show here is the demo that I made using AR Foundation and the lightweight render pipeline. And really the goal of it is to show some cool visual effects and how you can take all the cool stuff that we're doing at Unity and put it in AR. So the first part of this demo is kind of a fun part where we're going and kind of placing plants around. And it's kind of using this more kind of painting here. Do that. Whoa, that one's kind of floating there. But you can see we've now kind of quickly placed content, and now we're going to bring our character on stage. So there she is, and you'll notice a couple things going on. So first, the character has a shadow, so she's casting a shadow on a transparent plane, which really kind of grounds her there in the environment. And we can also do some cool stuff. Since we're using the lightweight render pipeline, we get access to things like the shader graph. So we can do some effects where she kind of goes transparent, and now you can actually see the real world being kind of refracted through her body, as well as the digital objects there. Of course, we can kind of bring her back, and notice that her shadow actually disappears as her kind of body does as well. So that's kind of cool. And then just to kind of, a little bit of a cherry on top, we also put the spaceships from Mega City here in AR. So there's 1,000 of them, 2,000. We can actually just start adding lots of different spaceships here, and you can see that we're still hitting 60 frames a second. All of our content's locked down there, and now we just have thousands upon thousands of spaceships up top. And this is because we're taking advantage of the data-oriented tech stack, which is a big initiative at Unity, kind of as we build out more scalable, larger scale games and applications. So you can see that. And as I kind of move around, you can see through a little bit, stuff like that. All right, so now what I want to do is just break down a little bit about how this demo works. There we go. So here we are in the Unity editor. What I've actually done is instead of using just a normal skybox or no skybox, like we're going to see when we're bringing the content here into AR, what I'm doing is I went ahead and just threw a skybox in here so we can start to test and understand some of the effects and how they work, just to give a visual reference rather than the default skybox. So the way this project works in Unity is we're actually using a timeline. So our timeline is our character animation. She just jumps out and comes on stage. And then you'll notice that her shadow there is actually just this plane that's kind of at the foot of the object. So you kind of place that at the base. So when you place that on the floor, then she starts kind of casting this shadow. And I'll go over a little bit of how this works through the shader that we're using for that. Now, her effect is actually basically blending out the geometry of the main animation, and then we're just swapping or placing a hologram body of her right there as well. So let me just bring her back here. Whoop. And you can see, let's go here, like that. And then what we're doing there through the buttons is we're basically just toggling here, using this effect to kind of turn her off. And then you can notice the refraction going on. So the refraction is basically a special shader here. And the cool thing is, because we're using Lightweight Render Pipeline and AR Foundation, we're able to basically pull in the opaque camera render or camera texture, which allows us to get that visual blending of the real world and the digital objects. And you can see here in the hologram, let's go right here. In the hologram shader, we're basically just kind of applying a generic noise texture here, and that allows us, there she is, and we can easily kind of swap this out for different noise textures, and it's really just kind of determine how those refractions are kind of being bent through her, and things like that. And the other thing to note here is these are just kind of the plants here. Again, just random prefabs that we're kind of placing around. All right, so as I mentioned, we're using Lightweight Render Pipeline here. In the current version of AR Foundation, in the 2018.x series, there is support for 4.8. This is available on the AR Foundation samples branch for the Lightweight Render Pipeline support. The goal is to get up to the 4.10 support in the 2018 LTS version, and then of course moving into 2019, once the Lightweight Render Pipeline becomes a verified package, we'll of course verify it with the AR Foundation support so that you can start utilizing that and all the kind of new features that are coming in the 2019 cycle. And now I just want to break down a little bit about how her lighting actually works. So basically, we're using something called light estimation, which I forgot to show there in the demo. But what that means is that it's taking the kind of ambient light brightness value from the camera frame and then applying that to a directional light in the scene. And that's what allows her to kind of get a little bit darker or get a little bit lighter as the environment changes. So for her shader graph, we're using just the standard PBR shader graph, which allows us to just get that lighting data for free. All of the lighting is driven via a real-time directional light, so we see those updates in real time. Now, one of the things to keep in mind is that when we originally implemented this, the lighting data actually ended up kind of becoming too dark. So this was kind of the initial problem area that we had. And so we're doing a little bit to kind of multiply that lighting data, brighten her up a little bit, and really pulling that lighting data into these custom nodes so that then we can apply it at a more kind of normal value so that it doesn't look as dark, but you still get some changes in the light estimation, and you still kind of have her match that scene in the environment. And the way that we're actually using it in the shader is we're just outputting it through the emission, which just ends up kind of brightening her or darkening her a little bit in a more natural way. The way the refraction is working is basically a combination of the settings in the Lightweight Render Pipeline asset that you use, as well as a single node in the shader graph. So what we do in the Lightweight Render Pipeline asset is, I can show you guys here. So right here, there is, let's see if we can get the zoom in. So there, in the general settings, there is something called opaque texture. Once you check that checkbox, then it allows you to actually pull in that camera texture and use it as the entire kind of grab pass, if you're familiar with that, in shader programming, so that then you can use that to affect both the camera feed as well as the digital objects, since those all get rendered out to that opaque texture. And then it's just applied in the a single node within the shader graph, so so that you can start doing things like refraction or using that in kind of more interesting or unique ways. And you can see here, again, we're getting the background of the camera feed as well as the digital objects, since those are all rendered to that opaque texture. What we're doing with the actual refraction here is we're basically, one of the goals here was that we want her to be transparent, but we still want to know that she's there. So we're actually doing things like taking a transparent texture, but still applying and rendering a normal map. So you can still kind of see her outline and her edges. She's not like a flat, she's not a flat render there. It's still the 3D geometry. And really we're just kind of outputting that along with that noise texture that I highlighted earlier to kind of show you how things get refracted through her. And then of course we're just scrolling the UVs as kind of a classic technique to just look like she's kind of moving and still there rather than just being completely static. And one of the things that I try to do a lot when I'm creating any sort of kind of AR application, whether it be something like this or just small demos, is really think about and consider shadows. So in the real world, we see shadows on almost everything. And in AR, more often than not, people are just kind of placing content. If there's no shadows or there's no kind of visual indicator of where that content lives in depth, it can be a little bit confusing as you kind of move around, as you look at it from different angles. So what we're doing here is we're actually created a custom shader. Originally we created it in Shader Graph, but we went through and kind of rewrote it to be a little bit more optimized, so that if we ended up having more 3D objects or things like that were also casting shadows, it would scale up with that. But as mentioned earlier, we kind of place it on a single plane at the base of the prefab, and then you're able to kind of cast the shadow here on a transparent texture. Now, this works great for kind of full characters where you want that full body texture, but when you look at things like the plants, we're actually using kind of a more classic technique that you see a lot in mobile gaming, and we're using little blob shadows. So we actually have just little transparent kind of shadows here that we put at the base of each of these textures, since it's a little bit more performant rather than casting completely accurate shadows for all of these plants. And you can see we've even shaped them a little bit right there. And again, this is just kind of a grounding technique to help your content look a little more in the real world. And yeah, the one thing to keep in mind is, we are using the lightweight render pipeline. So when you author these shaders, you need to include those new libraries specifically to take advantage of the lightweight render pipeline. You don't necessarily get this stuff out of the box, but it was a fairly kind of straightforward shader. And I don't think I mentioned this yet, but the goal of this demo is to distribute it. So if you guys saw something you really like or are interested in kind of getting these effects, getting this shader, expect that to be released in the coming months. And then lastly, I just kind of wanted to highlight quickly the plant placement. So the way that we're doing this, you might have noticed that it goes kind of rather quickly, and that's because we're using both feature points and found planes. Feature points appear a lot more quickly, and as you kind of scan around, we're basically doing a raycast into the world, so using a frame raycast against feature points or planes. And then from there, we're doing an overlap sphere to check if any of the plants are nearby. And I've actually attached colliders to all of the plants so that they don't start to overlap. So as I'm scanning around, we're looking at those feature points, we place a plant there, and then as we kind of move it around, or the next frame, we're doing an overlap sphere. If it doesn't overlap with any of the the already placed plants, then we go ahead and place another one. So this was kind of a fun technique where we ended up getting it really early into the demo, and it was kind of way more fun and way more popular than I originally expected. Originally, it was kind of just supposed to set the scene for when the character comes in. And as mentioned earlier, we're using blob shadows just for those plants specifically, not using kind of shape accurate shadows. And then they are using very similar shaders to the terraformer. So we have a little bit of that toon look. They're also being affected by light estimation. All right, so that's pretty much it, kind of breaking down the demo, showcasing how you guys can use lightweight render pipeline in AR Foundation. And I think we have a couple minutes for questions, and thanks for grabbing my jacket. Any questions? Hello.
Hi. The remote that you showed, so that's connecting wirelessly? Is it streaming over Wi-Fi, or how's that connected to the editor?
Yeah, so you can connect it locally. It does have to be through kind of a switch, so you have to connect your device to a dongle to the same kind of switch, and that allows you to connect it locally, but it can also run over Wi-Fi. We have it demoed at the booth over there that we're showing it off, and basically it's on kind of a closed network, so both the laptop and the device are on the same Wi-Fi. You just type in the IP address, which you get from the remote app, and then you just kind of hit play, hit connect, and you can start scanning around and then placing content in the world by clicking in the editor.
Awesome, thank you.
Yep. All right, so I'll be around the rest of the day. If anyone has any other questions, I'll probably be hanging out at the AR booth or around the theater here for a bit. Thanks.